right, part 2 of yesterday's test. Number 8 in a standard 52 card deck was the probability of drawing a red card followed by an ace. So you have two scenarios here. One of them is the red card is an ace, and the second card is also an ace. Now there are two red aces in a deck of 52. So I pull a red ace, and then I grab another ace. And color doesn't matter here, it just has to be an ace. But there's only 3 aces of 51 cards. Or the scenario 2, the red card is not an ace. Now there are 24 red cards that are not aces in a deck of cards. And then the second card is an ace. Well, since I haven't actually pulled an ace, there's still 4 in 51 left over. So let's see what this generates. We got a 2 in 52. Then we got a 3 in 51. We had the word or, and or means add. There are 24 in 52 red cards that aren't aces. And then there's 4 in 51 aces. Math, enter, enter. And we get 1/26. Choice A. All right, number 9, if the probability of event A is 9/31, what is the probability of the complement of A? The complement is simply found by doing 1 minus the probability of event A. So this is going to be 1 minus 9/31. And forgive me for being old school, but the number 1 is 31/31. 31/31 minus 9/31 is hopefully 22/31. And I know some of you are like, wow, that's magic. No, it's not, bruh. We watch this, because you'll believe the TI-84, which was programmed by men. 22/31. All right, number 10, a survey of 120 students was completed at DHS, that's Dresden High School, for you who don't know that. They say we need 3 circles here. The survey discovered that 67 hated teacher M, so there's a circle for teacher M. 45 hated teacher C, and then 33 didn't really like teacher G. 11, let's see here, let's start here. 8 students hated all 3 teachers. Remember, there's 120 kids out here too, by the way. 25 hated, sorry, let's start here. 12 hated M and G. So 8's known, that leaves 4, because 4 plus 8 is 12. 11 hated C and G. Well, 11 minus 8 is 3. Let's see here. 25 didn't like M and C. So here's M, here's C. There's 8 there. I think 25 minus 8 is 17. I feel like it is. And then we can start filling out some circles here. Now it says 33 did not like G. Well, if you look at G right now, you got 4 and 8, which is 12. You got 15. That means that there are 18 kids left for that circle to be complete. 45 disliked secret teacher C. So there's 28 currently. 3 and 17 is 28. We need to get to 45. I feel like that's a 17. Yeah, it is. 67 did not like teacher M. Let's see here. 67 minus 17 is 50. Minus 8 is 42. Minus 4 is 36. And again, this needs to add to 67. So we got 12, 29, and there's something wrong, isn't there? Now is it 67? 67 minus 17 is 50. Minus 8 is 42. 38. That's the problem. All right, there's my 3 circles. How many students do not hate any of their teachers? So let's see what's in here, and then we'll take it away from 120. So we got 38, we got 17, we got 8, we got 4. That takes care of the M circle. That was 67, good. And we got 3 and 17. Okay, so I've done all this, and I still got 18 to talk about here. And that tells me there's 105, and you know, 120 minus 105, I hope it's 15 or something wrong with me today. 15 kids. Find the probability of hating M given they hate C. Okay, so the given part is always the denominator. See how that looks kind of like a denominator? So I need to figure out how many kids are in the C circle, and I can do that by reading. It says there's 45. So this is going to be out of 45. And I know this bothers kids because none of the answer choices were out of 45. You guys still think that it's as easy as knowing one little thing and being done with it. It's not that easy for most things. Now, of those people in the C circle, there are 25 who don't like teacher M. And I have a fraction and I reduce it. 25 and 45 are both divisible by 5 last I checked. It's 5/9. How many students hate M or G? All you got to do is add the stuff that is in M and G. Now I know that this circle right here is 67. If I add 3, I'm at 70. If I add 18, I'm at 88. How many students hate M only? Just M. Just me. Moi. Be that right there. 38. All right. BRB. A weighted coin is tossed. The probability of getting heads is 60%. The probability of getting tails is 40%. What is the probability of head, tail, tail? So the probability of getting a heads would be 60%, which is 0.6. And then I get a tail, which is 0.4. And then I get another tail, which is another 0.4. Choice C, kids. All right. Two-way table below summarizes how some of the students at school travel to school. Complete the two-way table and work out how many students go to the school in total. So you guys had this guy 2 days in a row. You should have mastered it. But grading, first and fifth, I can tell you, you did not master it at all. Let's see, here's the easy one. That's 60, right? Let's see here. We know what 54 minus 17 is. Got 37. 52, 37, and 31. I feel like they add up to 120. We got a 52, we got a 37, we got a 31, got 120, add down 210. We need to do some takeaway here, right? So we got 90 minus 29, which is 61. And we got to take away 17 more, which is 44. Then we add down, we get 96. And now we're ready to actually do these things. The N means and. Find the probability of other and a girl. Other and a girl. There are 29 individuals who are other and a girl out of 210. Some of you guys had probabilities that were just wrong. Like, I don't know where you came up with your numbers. And I didn't bother to go back and look at your table and figure it out either, but they were just really off. The probability that we don't walk, well, that would be the probability that we ride the bus or other. So there's 54 and 60, there's 114 people who do not walk out of 210. And this fraction does reduce quite a bit. We'll just do it the easy way here, because for some reason I don't think y'all realize you can do this. 19/35. The U means or. You're a boy or you walk. Boy or you walk. Okay, so here's my walking. And these two things are still boys, right? So we've got 120 in this row, plus 44 is 164. It's out of 210. And this one reduces quite a bit too. A2 over 105. All right. Number 4, the probability of other given you're a girl. So there are 96 girls. That's your denominator. Remember, the given is always the denominator. Of those, 29. So it's 29 of 96, which does not reduce. 29 of 96. No, that's not right, actually. Sorry. Looking somewhere else. There are 90 girls. There we go. That's better. 29 are the others. 29 of 90. All right, 13, a six-sided die is rolled and a spinner with the letters A, B, C, D, E, and F is spun. Find the probability of rolling a 2 and spinning an E. This one really blew my mind. You've got a six-sided die. The probability of rolling a 2 is 1 in 6. And then you spin an E, which also happens to be 1 in 6. It's 1 in 36. I don't know why so many of y'all missed this. Then we have the word or, and the only difference here is the word or means plussing. That's 1 6 plus 1 6, which is 2 6, which is 1/3. I've already done 14 and 15. 16, how many different ways can I arrange 6 different students? Well, if I have 6 kids in front of me, I can pick one of 6. I've picked him, now I can pick 5. I've picked him or her, now I can pick 4. I've picked them, now I can pick 3. I've picked them, now I can pick 2. And then 1. It's 720. It's the fundamental counting principle. 17, how many gibberish words can be created by rearranging Massachusetts? So Massachusetts has 4, 8, looks like 13 letters in it. Let's check that. We got 4, 8, 12, 13 letters, so 13 factorial. The letter A happens 1, 2 times, so I'm going to put that over 2 factorial. The letter S happens 1, 2, 3, 4 times, 4 factorial. And the letter T happens twice, 2 factorial. And I don't think anything else repeats like that. So it's this gigantic number. So let's see here. Let's go to math, num, n over d. We got a 13 math probability factorial. That is sitting pretty over. Order doesn't really matter, but I wrote it 2 factorial, 4 factorial, 2 factorial. So 64,864,800. Almost done. Committee of 7 members is to be randomly selected from a group of 9 freshmen and 7 sophomores. How many different committees of 3 freshmen? So there's 3 freshmen of 9. That's going to be 9, choose 3. 4 sophomores, and this is multiplication. So we depict 3 freshmen and, which means multiply, 4 sophomores. Let's see here, 4 of 7. So 7, choose 4. So 9, choose 3 times 7, choose 4. Choice 3. All right, Annie has 4 dozen eggs, 18 are white, 18 are brown, 12 are blue. Annie is going to be making a few cakes today and needs to use 18 of her eggs. What's the probability that exactly 8 are brown, 5 are white, and 5 are blue? She's going to use 18 of her eggs out of 48. So the denominator is 48, choose 18. It wouldn't surprise me if there were kids who didn't know what dozen meant. Nothing I can do about that. 8 are brown of 18, so we have 18, choose 8. And 5 are white, so we have 18, choose 5. And 5 are blue, 12, choose 5. This is what I push buttons on. Which one it was, I can't remember. So just bear with me for a minute. Or maybe, I don't know, play along. You know, something like that. Or complain how hard Milbrath is and go talk to the guidance counselor about how unfair he is, that he does all your work for you. And all he does is he asks that you learn. You know, do that too. Cool. It's all me. It's not you. Point 0406. Choice C. How many ways can a class president, vice president, and secretary be picked from a group of 18? So you'll notice that there's 3 things here, and it's order, so it's a permutation. There's 18, pick 3. And that's really all you have to do is 18, pick 3. So it's 18, probability, NPR, 3. 4,896. A lot of kids say 816. I think they did a combination. And the last one, it's actually which statements is true. I gave you full credit if you got one or the other. All right, so is this statement true? The union of A and B is D. If I take A and union it with B, I would have a 10 all the way to a 16. And I would add what's in B, which is, B, which is 17, 18, 19, 20. Very few kids actually bothered writing this stuff down. I guess you just did it all up here, but it's not choice one. Choice one is false. All right, 2 talks about the intersection of C and D. Okay, so if I intersect these things, it's what do we have in common? It is empty. So this is true. All right, 3 talks about the intersection of, the union of A and C. And what is the union of A and C? It's going to contain 10 through 16. And then it's going to contain, it's already got an 11, it's already got a 13. It's going to contain 17 and 19. And if you'll look up here, this is also true. So those 2 statements were true. They are true. All right, and then we have this one, 4, which is A and C. So if we union A and C, what do they have in common? They have an 11. They have a 13. They don't have a 17, and they don't have a 19. That's it. This one's false. So my 2 statements were 2 and 3 only. And that's it. I'm not going to do the bonuses.